Hello, everyone. Welcome back to our final presentation of the first day of the specialty workshop. We have Mohammed from Siemens with us. He's an application engineer at Siemens Digital Industry Software, and he's going to talk to us a little bit about how to develop great mechanical drawings. Before that, I just want to express my appreciation for the partnership that the Solar Car Challenge has had with Siemens, and they have made it possible so that every team could go and apply for a grant to be able to get this, great software, this software that industry uses to do CAD, to do electrical drawings, and they make that available to you as Solar Car teams. And you heard a bit of that earlier today with Brian Coleman from the Kentucky Solar Cats team, who they used Solid Edge software to be able to develop some really great mechanical drawings and electrical schematics. So thank you, Mohammed, for coming and sharing with us how to use Solid Edge.
Thank you, William. Let me go ahead and share my screen. Hello, everyone, and welcome to our session on developing great mechanical drawings. So we're going to be learning about, the basics of mechanical drawings and how we can take advantage of, what Siemens has to offer. So just as an introduction, my name is Mohammed Sajjad, if you don't know already. I'm an application engineer, and I am part of the Solid Edge academic team, and I will be presenting about developing the mechanical design and schematics. And my colleague that you see, Mike Ashbaugh, is the business development manager for Solid Edge electrical design products, which he will be presenting about tomorrow. So be sure to tune in for that presentation. So it's very important to understand that, Solid Edge is so much more than just a CAD system, right? Sure, it has the best mechanical design in the marketplace, but what about the rest of the things that you need to do as a business? We have things like electrical design, simulation, manufacturing. They're all part of the Solid Edge portfolio, along with technical publications, data management. And, no matter how small or big you are, cloud-based collaboration is very important these days, in these times. So today we will just focus on the mechanical design portion, and more specifically, the 2D design and drafting. So just before we get started, I just want to mention that, you can go to this link, you can scan the QR code or go to this website and you can access, get all the details about all the different things we have in the Solid Edge portfolio, and as well as finding additional resources such as projects and tutorials that you can use to learn how to use Solid Edge. And as well as, you can find the link for the academic grant that we have that provides you access to the entire Solid Edge portfolio. So the first thing that, we must understand is that all the products that you see around you every single day, they're all designed, everything from Lego blocks to toothbrushes, sometimes people have prosthetic limbs, those are designed as well. And even, something as large as a space shuttle, imagine how much design goes into launching that into space. And it's not just limited to mechanical products, you have electrical products as well, that require schematics. And, designing is important for industrial products as well. So they can figure out, for example, the layout of the plant or how to optimize manufacturing process for, a product or something like that. So design is very important and is used for every single product, if not all. Now, imagine for a second if, all the things that we talked about were created without any design or any plan, what would happen? Well, the biggest risk is that it would fail to function properly, and it would cost, whoever created it, it would cost them resources. And that's exactly what the benefit is also, the flip side of that is that the benefits of designing is that it reduces the risk of something failing. And in return, that saves companies money and other resources like time. So now, when we talk about designing does not just mean, complex engineering drawings or schematics, It can be just simple as a drawing on a napkin. Or, how about this? You've probably done this before, just doodling something in your journal or notebook. People do that all the time, right? And in essence, all those are examples of design, just very basic, but nonetheless designs. And that's basically how design process starts. And that brings us to solid edge 2D drafting. So that is where the 2D drafting comes in. So what it allows you to do is that offers simple drawing layouts, diagramming, annotations, and dimensioning controls, that automatically comply to the drafting standards. That can include, for example, the international standards, which is the ISO, the American standards, ANSI, or the British standards, among others. And also, it's very important to be able to open up the file, bring it in from other software as well. So you can start your drawing from scratch or bring it in, using the DWG file, which is an extension. So when you're finished, you can also save your file as either a solid edge or a DWG format, and it allows you the flexibility to collaborate, with your peers, with your partners, or, with your teachers, and automatically, it very easily allows you to open up the 2D CAD files in any 3D CAD, program that's out there. So now with that said, let's look at some of the specific capabilities of solid edge 2D drafting. Now, when you're creating a new draft file, you can select from a standard of your choice, like we talked about, some of the standards that we talked about, the international, right, which is the isometric, which you see, the American standard, which is the ANSI, and British standard, BSI, and then, inch or metric. So there are different standards that you can use to create the draft. Now, users can either create a new draft, completely from scratch, or if they have a model that they have already created and they want to, create a drawing of it, they can use the command, which is the drawing of active model. So they can easily create the drawing for the model that they already have. So it allows you that flexibility and gives you that choice. Now, we'll look at some of the commonly used commands in solid edge 2D drafting. One of them includes the view wizard, which the view wizard allows you to, create standard drawing views. Some of them include, principal view, auxiliary view, and among others. So we'll talk about this a little bit more, in detail. So specifically about the view wizard, this is used to create the initial views that you want to place on the drawing. And, users can customize the settings, such as the angle view, like whichever angle you want to include, whether it's the front, the back, left, right, however you want, as well as, the type of shading you want. So you can get very specific with that. Now, after you've placed the first initial view, which you see in pink, what you can do is use the principal view command. And what it does is derived from the initial view, and based on where you move your cursor, that's the view that you're going to get. Meaning that if you move your cursor towards the top, you're going to get a top view. If you move your cursor to the side, you're going to get a side view. And then if you move it diagonally, you'll get an isometric view. So that's how the principal views work. Now, after the initial and principal views are placed, they can be easily edited and manipulated simply by clicking and dragging. So Solid Edge allows you that flexibility and very easily make changes. And since those views, like I said, are derived from the initial view, they will remain aligned to that view so that it allows the user to modify the drawing and place them as necessary. And it makes it easier to understand, okay, so if that is the initial view, and based on that, this is the top or the side view. Now, another nice feature that's available is the cutting plane. Now, cutting plane is used for creating a section view of a model. And we'll talk about section view next after this. And so you can create the cutting plane by simply sketching the cutting line, right? So you're telling the software, okay, I'm going to be viewing from here to here. So in this example, we used a staircase, like a zigzag type pattern. And you can create the cutting line however you want, the cutting plane. It can be straight, completely straight, horizontal, vertical, or like you see here on the screen. And so after you've created the cutting plane, the section view command can be used to create the cutout view of the model. So in this example, imagine if the model was cut along the dashed line and then placed flat on the disk. So what you would see is the view that's on the bottom. And the same thing can be done for, something that's circular or cylindrical model, which you see on the right. So this cutting plane is used, it's created first to be able to allow you to create a section view. Now, another very useful command is the detail view command, which allows you to create a separate zoomed in view of a model. And this is very useful in highlighting details or like small features on a model. And this can be done simply by selecting where you want to place the center of the circle, where you want to see the the center of the detail view, and then how big you want the diameter of the view to be, and then clicking and placing that detail where you actually want to place the view. So dimensioning is very important when you're working with 2D drafting. Without dimensions, if you wanted to go from a design to a manufacturing, it would be very difficult. So, these are some of the tools used for dimensioning. And that includes, if you can see the smart dimension is the biggest one. And I think it's one of the most important ones. And it, automatically allows you to place a dimension simply by clicking on a line, an arc, or a shape. And another one that's really important is retrieve dimension. And it's very useful because it allows you to retrieve dimensions that were placed on a 3D model. So if you create a 3D model and you were to create a drawing of it, you can automatically bring in the dimensions that you put in the 3D model into the 2D model. So it's very useful for that. And just like dimensioning, annotations are also very important, letting anyone who views a drawing know important details about the drawing. Something that can't be captured in a view can be, portrayed in an annotation. And we'll take a look at some of these features next. One of the commands is the Centerline command, and what it does is it basically places a reference line in the center of a cutout or a feature. Now, this can be customized to different colors, line type, and width. And once the center line is placed, you can grab the select tool and move it, move the handles if you wanted to, and stretch it or shorten it, if you wanted to, for example, for putting dimensioning at a later time. So the center line is good for letting someone, who's viewing the drawing know that, hey, this is a cutout or something like that, and this is the center of it. And just like, the center line, the center mark command places a center mark on any circular feature, such as a hole or arc. And if there are multiple holes in a drawing, what Solid Edge, allows you to do is select multiple holes at once, by simply dragging a fence around them. So you can just fence select all the ones all at once. So it's something, neat and allows you to do that really easily. Now, user can also, create a text box with specific instructions, or if you wanted to highlight feature details that aren't shown on the drawing. So that's what the texts are useful for. And you can, of course, adjust the size, font, and borders and everything. And another thing you can do is place leaders. What leaders allows you to do, and if you place a leader, you can connect the annotation to the reference feature. So like you see in the picture, it says note, break all sharp edges, and it's pointing you to exactly where on the model it wants you to look at. So it's good, really good for reference. And the callout command is very similar to text box. However, it's only used for a specific purpose, which is calling out features. You can use special characters such as depth or diameter, and they can be used to pull information for the callout directly from the graphics. So for example, the diameter, you could pull that directly from the model. You wouldn't have to type in 6. And also in 2D drafting, we have different types of table that can be, placed in the drawings. For example, such as the parts list and other things like holes or bend tables, many other things. And, these tables commands, they automatically retrieve and display the information from the part or assembly document. So meaning that you don't have to manually type in, okay, this is part 1, part 2, part 3. When you place a parts list, it automatically auto-generates that. So you don't have to do anything, simply just place the parts list or a holes table or a bend table. So more specifically, if we were to look at the parts list command, this places a parts list like I was talking about. And if you were using like an assembly or a part, it automatically brings that into the drawing sheet. And like I said, this retrieves and displays the information from the document itself. So you wouldn't have to go in and manually type in, item number, name number, material, quantity. It is automatically pulled from the document. And then the information that's displayed can also be customized as well. Like you see on the left, you can customize, do I want to see item number, name, material, quantity? If there are parts that were made by different authors, you can also have a column, with author as well. And so whole different things, you can see in the properties dialog box. And then when you create a parts list, when it's placed in the drawing, it automatically places balloons on the parts, which are referenced in the table, which allows you to easily reference the parts, not only in the table, but also in the drawing as well. Of course, the balloon placement and the alignment can be adjusted as well. So it's very useful and it's good for reference for anyone who's looking at the drawing. Now this command, the balloons command, it places a balloon containing text. So you can use the balloon to refer to an element or to a point in space. And then you can, of course, control the size and the shape of the balloon, the text presentation, size inside the balloon, and the leader display as well. Now, if you notice in the balloons, you see there are two numbers, one on the top, one on the bottom. The top number is referring to the item number in the parts list, and the bottom is the quantity number. So it's very good and useful information for someone who's trying to look at the drawing, as well as, if you were to hand this off to someone else, they could easily look through that and find that information. And Solid Edge also allows you to make changes to the model. However, only in the solid model itself. So if you wanted to change the model, you would not be able to make the change in the drawing, but you would have to do it in the 3D model. Now, Solid Edge makes it easier for you to open the 3D model simply by double-clicking on the drawing view or using the edit menu, and it automatically activates the 3D model. So just simply by clicking on the drawing, you would open up the solid model where you can make the changes and then, and come back to the drawing and it will reflect that. Now, after you make the changes to the solid model and you save it and then you go back to the drawing, what you'll notice is that there is a gray box that will be displayed around the view. And what the gray box means is that simply the drawing view is out of date. And that's because, remember, you edited the model itself, right? So that's no problem at all. You can simply select the update view button and it automatically brings the drawing up to date, all the views. And so another cool feature, which I really like, is so when you update the views, and if you've changed some dimensions, you'll get a little pop-up dialog box. And what this is the dimension tracker. And it's simply letting you know that some of the dimensions have been changed. And it's good because, if you make a lot of changes, you can easily, lose track of all the changes that you made. So the dimension tracker will, very easily let you know useful information, such as exactly which dimensions were changed, what it was changed from, the old value, and as well as the new value. And, when you're done viewing the changes, you can simply clear them and then close the dialog box. Simple as that. So, we learned some of the features in Solid Edge into, Solid Edge 2D drafting. Now, let's take a look at some of these in action. So, you start by selecting the draft environment. You can choose any standard. In this case, it's ANSI metric. And after you click the standard, then you click on the view wizard. Right after you click on the view wizard, you navigate to the part that you want to open up or the assembly. And this will automatically, place a preview on your cursor, which is going to be an initial view. So you can lay out different multiple views. So in this case, if we wanted to put in multiple views at the same time, we can do that as well. And you can move them around wherever you like. Now, another way to place views is, like we talked about, is using the principal view command. So after you click the principal view command, select the view which you want to refer to, and then you move your cursor. So wherever you move, you see the view. So if I move to the top, I get the top view. Now, notice that if you place the orientation of it wrong and you want to change it, you can easily do that by clicking on the view orientation and then changing the orientation however you want. Notice when you did that, notice the top view flipped around, right? So you can make changes, and even if you've placed it, you can make changes. And then using the principal again, you can create the isometric view as well. And then you can also change the scale as well as, if you want it shaded, not shaded. Now notice when you place the isometric, it created a gray box around it, and that's because it's not updated. And you can simply do that by clicking on the update view button. Now, another thing is, for placing the section view, you have to have a cutting plane. Now, you can simply start by placing the cutting plane. This can be any way you like we said, straight, zigzag, however you want. If you want to take it through center of a cutout, center of a hole, you can do that as well. Now, after you close out of the cutting plane command, the next step is to decide which direction you're going to be viewing the cut from. So in this direction, we want to view it from the left, right? Or, look at it towards the left. Now, what you do, you go to the section view. You add the section view using the section view command, and then select the cutting plane, and then you can move the cursor right to place the section view. Now, another thing we talked about is the detail view, which can be created using the detail view command. And then you select where you want to view the details, and then you simply place wherever you want to, place the enlarged view. And again, you can change the scale of it as well. So these were some of the, highlighted features of Solid Edge 2D drafting that we talked about. Now, drawings do not have to be complex by any means. Sometimes keeping it simple can be the best. So I do want to give a shout out to the Kentucky Solar Cats, who were the first place winners last year in the mechanical drawing competition. And they did an excellent job in, applying their knowledge, not only in the mechanical drawings, but also electrical schematics as well. So great job, that team. So very, very nicely done. So in summary, some of the key features of Solid Edge 2D drafting are, full suite of production proven 2D drawing tools, annotation and dimensioning that complies to a standard, diagramming for not only mechanical, electrical, and other schematics, fast and easy, parametric drawing layout, and then as well as supporting viewing in many 3D file formats that can be opened in other software. And as you can see how, there are additional elements of the Solid Edge portfolio that are structured in this chart. Notice how Solid Edge 2D drafting is just one small component in the overall Solid Edge portfolio. So it is quite comprehensive. So what does that mean for you? So as competitors in the Solar Car Challenge, Siemens is making the entire Solid Edge portfolio available for use at no cost to you. The bundles include 8 of the most popular, tools in the industry today, including the MCAD, ECAD, and simulation tools, among others. If you want to take advantage of that, you can get an educator or a faculty that's associated with your school, and they can submit an online grant. And the website that we showed at the beginning, and also I'll go over it at the end as well. Or you can simply email one of us or ask Dr. Marks, and he can point you to us, and then we can point you as well. And to get you up and running faster as well, we have a whole complete library of curriculum, training, and other resources that are available on this site as well. Like I said, you can use the QR code, scan that as well, go to that site, and it contains everything that you need to get up and running, as well as certification as well. So, which is very important. If you pass the exam, you will get a certificate in which you can use and show your employer that you are certified to use Solid Edge. And with that, I want to thank you for listening. And at this time, if you have any questions, feel free to ask them, or you can email me at a later time as well. So thank you.
Thank you, Mohammed. I'll open it up for questions. So if there are any one of questions, feel free and type them into the chat or a Q&A. I will say that the features that Solid Edge provides really fit in very well with what we require for documentation in Solarcar Challenge. For example, what Mohammed shared with a detailed view can be used to show the roll bar clearance between the top of the driver's head and the bottom of the roll bar, and you can just bring out the details and draw a dimension there to show, yes, I meet the requirements there for how much space is in between. And then, of course, we asked that the drawings be provided in 3 views, tops, front, and side, and you can see how easy it was just to break that out for us. So it's been great to have this resource available to us, and I appreciate the partnership that Siemens has with us.
Absolutely.
Any questions? All right. Again, I think if you have any questions, Mohammed's email's on the screen, and we look forward to when we can meet in person again. Mohammed did a great job with us the last time in doing a hands-on project with folks who just brought their laptops in and drew things up. So we look forward to those days again.